morning again. Very warm welcome to everyone to come to the class this morning. Right. Last week we talked about the measurement of the chemical species, which is very important for our environmental chemistry studies. On the surface of the Earth, lots of area which is very difficult to get the data. So we need to use other methods to observe our Earth systems, including the atmosphere, and the hydrosphere, cryosphere, lithosphere, and the biosphere. So the observations are the keys to the understanding of our Earth's environmental systems. And we need to test our understanding. So there are basically three pillars for our understanding of our Earth systems. Can someone please help me have a look at the video recorder to see if when I write on the whiteboard, can it record it and write it? Is that okay?
Không hữu ích.
Is that possible right here?
Okay.
Okay. So the recorder can record here, right?
Yeah.
Okay, thank you very much. And how about this place? Can it record it to this age? Here?
Okay.
Okay, thank you very much. Okay, thank you. Right, so we need to have the observational data to show the status of our Earth's environmental chemistry. So for the Earth's environmental chemistry, we need to have three pillars. First, we need to have the data, right? And then we need to test. We need to have a theory to understand the data. And thirdly, we need to test our understanding, which means we need to test our theory. So these three pillars means three solid foundations. There are three solid foundations which are necessary for us to understand Earth's environmental chemistry. We need to have the data. Data is very important, and we need to have a theory to understand the data. And then we need to test our understanding by running the numerical simulations, by doing laboratory experiments, so that we will be able to understand, to make sure what we think we understand about our natural environment, our environmental chemistry is correct. And for the data collections, because for the Earth systems, including the Earth system, including the atmosphere and the hydrosphere and the cryosphere. Cryosphere means the ice, the glaciers, the ice, Arctic ice, and the glacier ice over the Antarctic continent and over the Arctic oceans. Lithosphere, right? Lithosphere and the biosphere. So we need to have data to cover each component of our Earth systems. This is very unique, my dear students. This is a very unique character of our when we study the Earth's environmental chemistry. So after you graduated from the university, if you want to conduct further graduate study in our country or go to other country, if you focus on the Earth's environmental chemistry study, you will be able to attend lots and lots of scholarship for you. So that means you don't have to pay for your study when you go abroad. For example, if you go to Germany, you go to the United States, you go to the United Kingdom. Right. So because the study of our Earth's environmental chemistry is very, very difficult. And it requires lots of data. So for example, here you see that on this map, the land surface area of the Earth is about 21%. So this map is enlarged over the high latitudes. But there are about more than 70% of the ocean area. So it is very difficult to get the data, and in that case, we need to be able to collect the data from the remote sensing. So the data collection, we use the satellites, airplanes, balloon, and the in situ measurement. In situ measurements means such as a measurement done on the surface. Satellites, airplanes, balloons, in situ measurements. And now we use lots of the drones, robots, so that they can be remotely controlled and they can collect the data. We use the robot. So this is a very, very interesting area. To collect the data. So these are all for the data collections so that we will be able to get information. So what you see here is the data collection using the airplane starting from 1984 and 1988 over the Arctic region, and 1984 on the eastern side of the North Pacific, and during the 1991 and the 1991 on the Pacific North, Western Pacific over this region, right? And this is over the central tropical Pacific region in 1983. And for the southern hemisphere, you see there's a measurement over the Amazon area. Amazon rainforest is the largest rainforest on the Earth. So the ecosystems, the biosphere over the Amazon area is very, very important for sustainable development of our Earth's environment. So we need to understand the Amazon area. So there were experiments during the 1985 and 1987 to collect the data over these regions. Also, over the southern and Atlantic Ocean, here you can see here, there's an experiment called TRACE-8, which was conducted in the 1992. So this is South America, this is Africa. So during this period, we use airplanes and also the satellite to collect the data over this region. The reason for this experiment is because from the satellite measurement, we found that the ozone concentration is very high over the troposphere, upper troposphere in this area. But if you consider this area is over the ocean, how come that ozone concentration above the ocean can be so high? That was a puzzle at that time. We do not understand what process leading to the enhanced ozone concentration over the southern hemisphere and Antarctic upper troposphere over this region. Okay, so we conducted the airplane measurement. The measurement was conducted by the NASA research aircraft from the NASA. So based on the data collected later, we discovered that the ozone concentration was high is because the precursor for the ozone production, they are released from the biomass burning, over the South America and over the over this region, South America and over Africa. This is the Sahara Desert. Sahara Desert is the largest desert over on the surface of Earth. And Amazon rainforest is the largest forest systems, the biosphere systems. Right. So from the 1992 GTE experiment, we find that biomass burning will emit loss of ozone precursor. Precursor means the chemicals, once they are released into the atmosphere, they will be photolyzed, be disintegrated into the product which will lead to the ozone production. So ozone precursors such as carbon monoxide and hydrocarbons. These are